Welcome everyone to Data Science for Everyone. Today we're going to be talking about Scala. In particular, we're going to be talking about Scala Collections. Now, Scala Collections are lists, sets, maps, and arrays, as well as a couple other things, but we're going to take a majority of our time and focus on these four. Now, Scala has a rich selection of collection libraries. These collections are containers of things. Okay, those containers can be sequenced, linear sets of items, and again, these are lists, tuples, options, maps, arrays, and these collections also have an arbitrary number of elements or be bounded to 0 or 1 element. Now, collections may be strict or they may be lazy. Now, lazy, what does this actually mean for us? This means that collections have elements that they can't consume memory until they are actually accessed. This is an example of ranges. We also have items that are mutable, and this contains a reference that can be changed. And we have immutable, and this is a thing that a reference refers to is never changed. Now, for some problems, okay, we have a mutable collection. All right, and we also have immutable collections, and they work, which work better. It depends on what the situation is. When in doubt, it is better to use an immutable collection and change it later on if you need mutable ones. Now, in this section, we're going to shed some light on the most common uses of collections and their types, most frequently used operations for each of those collections. Now, let's go through what actually each of these items are. So lists, this is Scala's list, okay, and is a linked list of type T. We have sets, and a set is a collection of pairwise different elements of the same type. A map is a collection of key value pairs. Any value can be retrieved by its key. And then we have arrays, and this stores a fixed size sequential collection of elements of the same type. We will go into more detail for each of these as we go through the process. Now let's start out with lists. A list is a collection which contains a mutable data set, okay, or a data. Now, we also, a list represents a linked list in Scala, and then a Scala list class holds a sequenced linear list of items. Following are point difference, okay, so here we have a couple different differences between lists and arrays in Scala. Lists are immutable, whereas arrays are mutable in Scala. List represents a linked list, whereas arrays are flat. Now, let's quickly go over to our Scala console, and let's create something like val variable underscore name, and this is kind of just the basics of what we have. We have a list, and we would have its type, okay, and then we would have something like list, item 1, item 2, item 3. And again, this is just what a generic generic call would look like. Now we also have something like let me go back. Let's delete this really quickly. And we can also do something very similar. So we'd have a val, a variable name, and let's set it, we would something be like list. And again, this is how you would normally see people writing this out without the explicit calls to its type. And we'll go through this in a little bit more detail here in just a moment. So, collections in Scala, okay? Now, each element must be of the same type, okay? This is very important. Now, the implementation of lists uses mutable states internally during construction. In Scala, the list is defined under scala.collections.immutable. And then we also have a list of various methods, and we'll maybe talk about some of these. So add, prepend, max, min, to enhance the usages of the list. So let's get into some proper examples. Okay, so lists, again, this is a reminder, are immutable sequences of elements. And so let's talk about maybe odd numbers. Okay, so list, we have 1, 3, 5, 7, 9, 11. And then we can also need to understand that indexing items, we can index items, and they are, again, they start at 0. So this is very similar to Python lists in that instance. Again, we can go back and we can grab another one as well. We also have heads. So we have the head, and again, this will give us the first item in the list. We also can do a tail. Okay, and then let's just call the list by itself. And again, here we see that it is giving us the type of int inside of our list object here. Now we can also have, let's talk more in detail, and let's take a look at our types, okay, our element types. Now we can have, let's make a var my list, and we're going to have a list here. And now we're actually going to do a bit of mixed types here, to and true. Now what's actually going to come up here whenever we create this list is a list type of any. We can also have nested lists. So let's do val my list. Let's overwrite it, and we're going to have list 1, 2, 3, and then we'll also grab list 4, 5, 6, and then we can see here that inside of here our type is inside of our list is a list with type int. Now we can also have if something is a double or an int, it'll actually move through and turn the integers into doubles. So let's do val, and let's just overwrite it again with my list, and let's do a list of 1, 2.4, 5. And so we see here that it actually changes both of our integers of 1 and 5 into doubles. Now we can also have lists of tuple pairs. So val my list, and let's do a list of A1, oops, and then another tuple of B2. Whoops, and what did I miss? Where did I miss? Oh, whoops, there it is. We have our string literal. I accidentally had another parentheses there. You guys probably caught that while I was typing it out. So again, here we see that it will actually take our tuple, and it will tell us what each type is. So it'll be string, and it'll be an int. Now let's talk about some list operations. Oops, let me clear some room out so we can take a look. So list operations. First off, let's create a list. Let's do my list, and we want it to be 3, 6, 9, 12. So let's grab and make sure that we want to, you know what? Let's actually change this up a little bit. I want to add in 8 and 7 in there as well. So let's do let's take my list, and we do dot sort, or sorted, sorry. And what we actually look at here is that it'll sort our list for. So now we have 3, 6, 7, 8, 9, and 12. Now, if we also look back, my list, notice that it does not actually make that sort permanent. Okay. Now we can also grab the size of our list, and this is 6, because again, 1, 2, 3, 4, 5, 6. Okay, so a lot of times in other languages we'd use length, but here we use size. We can also grab the max value. We can grab the min value. whoops, not main, min. Okay, and let's clear some more space again. And let's grab something like, again, let's show my lists just so we can remember what it is. And let's do the sum. So on top of the list, my list, we can do the sum. We can also do the product. All right. Now we can also we can use a drop in order to do slicing. So let's grab let's create a new list very quickly. Val cap x. Let's do a list of 1, 2, 3, 4, and then let's say that we want to go through and do cap x dot drop 2. What this actually does is it actually goes through and grabs from the first, it grabs 1 and 2. It grabs the first 2 in our list. Now we can also do something similar, so x dot take right 3. And notice here it's going to go 3 over, so 0, 1, 2, 3. Okay, and that is now we can actually go back and we can maybe explore a couple other methods. And let's talk maybe about arrays now. Now arrays are a special kind of collection in Scala. It is a fixed size data structure that stores elements of the same data type. Now the index of the first element is 0. The last element is going to be the total of elements, -1, and it is a collection of immutable values. Now Scala arrays can be generic, which means that they will have that same type of array T, where T is going to be a type, okay, our type parameter or an abstract type. Now Scala arrays are compatible with Scala sequences, so that we can pass an array of T where there's also a sequence T is required. And Scala arrays also support all different types of sequent operations. So let's start off with another example. So let's do an array, and we'll say 1, 2, 3. And then we also want to, we can also overwrite val array, and then we want this to be, again, let's say A, B, C. Again, we see here that our arrays are going to now be of the string type instead of the int type. We can also use the range function, so array dot range, and then we can say from 0 to 10. And that is going to give us back an array starting at 0 and going up to but not including 10. Then we can also similarly do array.range, and we can say 0 to 10 by 2. And so again, now we have an array saying 0, 2, 4, 6, 8. Similarly, and sometimes this is a little bit easier to remember for people, instead of doing the array dot, we can just do a capital range and do the same thing. Whoops. Okay. And then so 0 to 10 by 2. Okay, and this is, again, this is going to be up to your preference. So just come to that and use that however you like in the future. Now let's move on to sets. So a set is a collection that only contains unique items. Now the uniqueness of a set is going to be defined by the equal method and the type of set it holds. Now if, again, you want to try and add a duplicate item to the set quietly will discard your request. So in Scala, both mutable and immutable sets are available. By default, Scala, they are immutable. A mutable is going to have a set that is defined under the Scala.collections.immutable. Okay, and then immutables are going to be defined under the Scala collection mutable package. Okay, now a set of various methods such as add, remove, clear, size also are used to enhance the usage as well. And in Scala, we are allowed to also create an empty set. Now also in sets, we can add new elements in a mutable set. We use the plus equal, plus equal equal, and the add methods are used again to add new elements when we are working with a mutable set. Now, the plus equals is also used to add new elements when we are working with a mutable set in the inside of an immutable collection. So now we'll also talk about, just in this little section, we're going to talk about some basic mathematical operations for sets such as unions, intersects, and the difference. So let's go over to our console. So let's create an empty set. And so again, here you can see that our set type is nothing. Now we can also overwrite. So S is going to be a set 1, 3, 4. And again, this is going to be an integer set. Now we can also do the same thing again. So just to show that we can, it will remove our unique values. So again, we see here that it is created a hash set. All right, and then again, this is removed all of the duplicate values. We can also show from mutable sets. So S is going to be collection dot mutable dot set 1, 2, 3. Oh, whoops. So again, I forgot to use the val here, because again, val is protecting our object. Now let's say that we have a collection. Again, this is a mutable set of 1, 2, and 3. If we do plus equal 4, now we're going to get another hash set of 1, 2, 3, and 4. It will actually add it for us. We can similarly do s.add 5. And this will give us a boolean of true. So then now let's take a look at our collection now, and it has added back in that it worked. Okay, let's grab s.max for our set operations. This is going to give us 5. We can also do s.min, which should give us 1. Now let's start out by casting maybe another. We can cast a list into a set. So let's my list, and it's 1, 2, 3, 4, 5, and then let's do my list dot to set. And notice here that this will cast my list to a set. Okay, so now let's go through some of our other more advanced operations, such as union. Let's clear this out. So let's create my set 1, and this is going to be set, and let's do 11, 20, 33, 22, 44, 55, 66, 77, and 111. And then let's create another set, my set 2, and let's see set, let's do 88, 22, 99, 44, 55, 66, 77. So again, a union, this is when we use the union, this could simply add one with set with another, and since the set will itself not allow any duplicate entries, we don't really need to take care of the common values. We can perform union as well. So we can say val s1 is going to equal my set 1 dot union my set 2. Okay, now similarly we can do an intersection. Okay, and to get common values, to get common values from both sets, we are going to use the intersect method. And again, this will return a new set which contains the common values present in both sets. So S2 is going to be my set 1 dot intersect my set 2. And again, we see here, now we just have the intersection of each. Now we can also grab the difference. between two sets using the diff method, and this will return a set which contains all that are not present in set 2. So val s3 my set 1 dot diff my set 2. And again, as we can see now, those that are different are 33, 11, and 111. Okay, now let's go over and look at maps. So a map is a collection of key value pairs. This is similar to a dictionary. Now keys are unique, whereas values do not need to be unique. Key value pairs can have any data type. However, data type once is used for any key, and the value must be consistent throughout. So maps are classified into two types, mutable and unmutable, or immutable. Now, by default, Scala uses immutable maps. Okay. Now, in order to use a mutable map, we need to go through and again go to collection.mutable.map and actually explicitly state that we want that. Maps can also be created in different ways based on our requirement and the nature of a map. We have different syntax depending on whether a map is going to be mutable or unmutable. Now there are three basic operations which we can carry out on a map: keys, and again in Scala this method returns back an iterable containing each key in the map. We have values. Now the value of the method returns an iterable containing each value in a Scala map and is empty. And again, this one is going to use a method which gives us true if the map is empty and false otherwise. Okay, so let's go back to our console and let's take a look. Okay, so again, maps are going to be a paired storage. This is similar to a hash table or a dictionary. So val my map, and let's go back to maybe something similar we had before. So A1, B2, whoops. And let's add one more, C3. And here we can see that now this is a map object with each of the type of string and int. Now we can do lookups. So we have my map, and we want to look up A based on its key. And again, this will return our integer of 1. Now we can also do my map get B, and here this will tell us whether or not if it is actually in there or not. So let's also try something that's not in there. My map get D, and here we can see that it comes up as none. So sum is basically saying that it's present and it's going to be at our index of 2. Let's also look at some mutable maps. So we can do temporary additions onto on immutables. So my map. Now let's do plus, and let's do D, and then we use some arrow syntax here, if I can get it right. And let's say that this is 999. So again, this will do a temporary addition to our immutable. Now if we want a proper immutable map, so my mute map, actually that's too long for me, mute map. So we go to the collection.mutable.map, and then here we're going to do x1 y2 and a1. Now here we can have permanent additions. So we can use our mute map. Plus equals is going to be, let's call this perm. And again, we're going to use an arrow, and we're going to make this 999 again. And so notice here now that this is permanent, whereas if we went to my map from before, we can see here that D is actually not defined anymore, okay, because it's not mutable. It was an immutable, and it was just a temporary addition to what we had before. Now finally, we can use my map.keys, and this will give us a set of our keys. We can also grab the values as well. Now this is going to be the end for today on talking about Scala Collections. I hope you guys enjoyed this, and if you have any questions, please don't hesitate to contact me. Thank you for watching Data Science for Everyone. Bye.